So we're continuing with talking about other characteristics of functions, intervals, extrema. Those are other ways we can describe characteristics of our function. So when we talk about intervals, we're talking about just values of x. So we're talking about maybe if you were looking at, so for this picture, maybe we're looking at the values of x between -2 and +2. We're talking about what happens to the graph, a description of what happens to the graph over that interval. So if we look at the interval I just described, between -2 and +2 on this graph, say, okay, well, what would I describe as happening to the y values? In this case, looks like the y values are all staying at y equals -2. So between x is -2 and x is +2, so between that x value, what happens to the graph? Well, the graph just stays the same. So what are our possibilities here? What could happen to the y values? Well, they could stay constant, which is what we're looking at, what's highlighted below. So constant would be they just stay exactly the same. They don't go up or down, they stay right at -2. What else could happen? Well, if you look on the left side of the graph here, over that interval, so I mean we could describe the interval, what's happening to the values of y, they're going down, so that's decreasing is another option, so decreasing being going down. If we're talking, I mean, just like you read a book, going left to right, that's how we read a function, read a graph. Decreasing constant, or if you look on the right side, the other option is the graph could be increasing over a specific interval. So in this particular function, you can see all three of those, and we could talk about how to make a function look like this, but that'll definitely come a little bit later. So if we did a brief example here, talking about, and we'll come to minimum and maximum in a minute, but increasing, decreasing, or constant, if we're talking about over the interval, you have to specify what x values, over the values for x that you're talking about, what interval, and more specific when we get into actual functions. But what values of x are we talking about? Well, looks like our x values stretch from -2 to +3. So -2 to +3. Over that interval, what's happening to the function? It's going to be increasing. There's no other portions to this function, so we don't have to describe multiple pieces, but in most functions we cover, you'll have some portions that are increasing, some that are decreasing, and some that may be constant. The other descriptor that's kind of, this is a good one to go with the basics, is that idea of extrema, are just your minimum and maximum values that you see. And generally we're talking about what we would call local minimum and local maximum, meaning that there may be other peaks and valleys, there may be other low points, other high points, but in that general area, that's the lowest value you see. So the minimum, we're talking about minimum value, maximum value. So obviously on this graph, the minimum value is this point, -2, -1. The maximum value is this point, 3, 2. These are pretty easy to identify, but when we're talking about minimum and maximum value, we're not really just talking about the point, you're talking mostly about the y value. So the minimum value, say, is at x equals -2 and is actually equal to -1. The maximum value is at x equals 3. The maximum value is at x equals 3, but the maximum is actually 2. So we're really, when you say the maximum and the minimum, you're talking about the actual y value. It occurs at a certain x value, but what is that y value? So we get into a little bit more complicated, and this is what we're going to be more used to seeing in the kind of graphs we're going to use, and that's why I asked you to bring your graphing calculator. If you graph this function on your graphing calculator, you can see that there's going to be maximum, minimums, areas of decreasing, areas of increasing. The one thing we don't see is there are no flat areas. There's no extended flat areas. Yeah, when this curve happens and you reach this valley down here and you have to turn around basically, there is not a flat area that we actually describe. Flat constant would have to be kind of an extended flat portion of your graph. So in this case, there is no constant portion. But if we're looking at, and I'll go ahead and highlight, looking at where we are decreasing, so we start with, and I'll go with yellow for decreasing. Decreasing, where left to right is our graph moving downward? Well, moving down, moving down, moving down, and then we make a U-turn, we start moving up. So this decreasing portion on the left side of the graph, then we make a U-turn up, and then we reach peak again, and we start going down, down, down. So the decreasing here, we have two intervals over which we're decreasing. And the quiz, I'll ask you some characteristic of this function. Decreasing, increasing, minimum, maximum, one of those. So we have the decreasing highlighted. And now we'll get the increasing portion. So we said the yellow portions were decreasing. The green portions we're going to say are increasing. So if I move from left to right, where are my y values going up? So if I highlight here, so we've got our intervals highlighted at least to show where is it increasing, where is it decreasing. And now we just need to describe where is it decreasing. So the graph's decreasing. What I want to describe is remember the interval, when you say decreasing, you're saying the x interval. What x values is the graph decreasing for? Well, if I look, and I mean, our graphs don't have arrows on them on our calculators, but if I look and say what x values are we decreasing, where again, you're going to use interval notation. It looks like, if I talk about this first portion here, and I'll label it with a 1, looks like we're decreasing, or we're going to be decreasing all the way from the very beginning of this function. The lowest value that we're going to be decreasing, looks like this stretches all the way to the left, and we're decreasing, 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 until we get to this bottom portion. Tomorrow we'll talk about how to find that actual point. But the point would be negative 1 point, it's really close to negative 1.58, comma, negative 9.25. We don't need to know how low it goes when we're talking about decreasing. All we need to know is at what x value does it stop decreasing. Well, the x values that it decreases over this interval would be negative infinity to, once it gets to negative 1.58, it's done decreasing. So to describe the decreasing in that first section, it's going from the very, very left of the graph all the way up to when it gets to negative 1.58 in the x's, it turns around and starts to increase again. Let's describe this other decreasing portion. So we'll label that as number 3. At what point does it start decreasing? Well, this point would be 0, negative 3. So it starts decreasing once it gets to 0. And then it continues decreasing until it gets to this point, 1.58, negative 9.25. So from 0 to what x values does it stop decreasing? Well, it stops decreasing when it gets to 1.58. Take a second, pause the video, see if you can do the same thing now that you have some points labeled on there. See if you can do the same thing for increasing. So I'm going to label this section with a 2 and this section with on the right as a 4. So number 2, you should notice it's increasing starts increasing at negative 1.58 for the x values, remember we're talking about x values, and then stops once it gets to 0. For number 4, for that 4 section, it starts increasing, starts going up, the y values start going up once you get to 1.58, but then keeps going right and increasing forever and ever. Generally, we're talking about increasing, decreasing. If you notice, I used, for the interval notation, I used the parentheses because we're talking about, it doesn't start increasing, it's not increasing at 1.58. It's after that it starts going up. Pointing out, and I'll just add it to this slide, maximum and minimum values here. This is where we talk about these local values, because if you look and see local maximum, local minimum, we have peaks and we have valleys, and that's what maximums and minimums are talking about. If you notice, though, this point 0, -3. This one peak we have in the middle. Is that the highest point overall in our graph? No, but it is a peak, and so we consider it to be a local. Right around there, it's a maximum value. So we do have a local maximum at x equals 0 of -3. And then we can't really describe, because the graph keeps going up and up and up forever, we can't really describe that as a maximum because we don't have a maximum value. Local minimums, these are actually both the lowest points on the graph, but they're each local minimum as well as overall minimum. At -1.58 and 1.58, there are local minimums of -9.25. So these are just a couple more characteristics. We'll talk about how to actually use this on your graph, or use this on your calculator tomorrow.